Hi everyone, today I will demonstrate a laboratory exercise which is cooling system fault detection. In this experiment, two artificial faults will be used to demonstrate the implementation of the diagnosis so we can easily observe the difference between normal and faulty conditions on the pH diagrams. Faults can be divided in two categories. The first one is hard failures, which either causes the system to stop functioning or not to meet comfort conditions. The second one is soft faults, which lead to degradation in performance but allow continued operation of the system. And the development of these faults within vapor compression systems can result in significant increases in energy consumption. A simple analysis of a standard vapor compression refrigeration system can be carried out by assuming first steady flow, the other one negligible kinetic and potential energy change across each component, and the last one no heat transfer in connecting pipelines. The steady flow energy equation is applied to each of the four components. What are these four components of the basic cooling system? The vapor compression refrigeration cycle has four main components. These are compressor, condenser, evaporator, and expansion device. This experiment setup consists of a hermetic reciprocating compressor, a fin-type air-cooled condenser, a unit-type evaporator, and expansion valve. And also, as you can see here, there are 6 solenoid valves: 1, 2, 3, 4, 5, and 6. And also there is a filter dryer, sight glass, and accumulator. For this, each main component is connected to each other by installing pipes. The refrigerant flows through each component by means of these lines. And for this experiment, we use R134A refrigerant. The inlet to the compressor is called suction line. It brings the low pressure vapor into the compressor. The suction line connects the evaporator outlets and the compressor inlet. After the compressor compresses the refrigerant into a high pressure vapor, it removes it to the outlet called discharge line. This one is discharge line. The discharge line connects the compressor outlet to the condenser inlet. The condenser changes high pressure refrigerant from a high temperature vapor to a low temperature and high pressure liquid refrigerant, and then it leaves the condenser a line called liquid line. The liquid line connects the condenser outlet to the condenser to the expansion valve. The high pressure refrigerant then flows through a filter dryer, as you can see here, and sight glass. to expansion valve. The filter dryer has two essential functions. The first one is absorbing system contaminants such as water, and the other one is providing physical filtration. And the side glass shows if the liquid line has a full line of liquid or if it has bubbles, which means it's a liquid vapor mix. These two components protect the refrigeration system and provide an important indication of any problem involving the refrigerant moisture or contamination in the system. The expansion valve meters the correct amount of liquid refrigerant into the evaporator. As the expansion valve meters the refrigerant, the high liquid changes to a low pressure, low temperature and saturated liquid water. The saturated liquid water enters the evaporator and is changed to a low pressure dry vapor. The low pressure dry vapor is then returned to compressor in suction line. Thus, this cycle then starts over. In this experiment, 7 folds can be created by generated. As you can see here, there are 7 generators. The first one, restricted filter dryer, restricted expansion valve, degradation of the compressor capacity, refrigerant undercharge, refrigerant overcharge, dirty condenser, evaporator fan failure. There is also temperature indicator. So the temperatures at 4 points can be determined. Temperature 1 is outlet of the evaporator and inlet of the compressor. Temperature 2 is the outlet of the compressor and the inlet of the evaporator. And temperature 3 is the outlet of the condenser and the inlet of expansion valve. And T4, the outlet of the expansion valve and the inlet of the evaporator. And there are low pressure manometer and high pressure manometer. So we can read pressure values for 4 points. P1 and P4 are the low pressures, and P2 and P3 are the high pressures. In the heat exchangers, pressure doesn't change, so P1 is equal to P4 and P2 is equal to P3. And also there's a multimeter that we can read volt, ampere and cos phi values. So we can calculate the electrical power by using these values. Let's start experiment. First, we turn on the main power, and for the normal condition, the fluid level in the accumulator should be in the middle. And then we wait until the system reaches the steady states. After the system reaches steady state condition, we record the temperatures, pressures, and electrical values. As you can see here, in normal condition, only 2 solenoid valve is open, 1 and 2. The other 4 is closed. I will send temperature and pressure and electrical values by email. So we can change the situation. As you can see, the suction line and discharge line is connected by normally closed valve 3. This is normal situation. But for the degradation of compressor capacity experiment, we turn on the generator 3. When we turn on the generator 3, the solenoid valve 3 will be open, and the others is closed. When we turn on the generator 3, the solenoid valve will be open. In this case, the hot gas will return from the liquid line to the suction line by pass valve. Thus, the refrigerant mass flow rate decreases in the refrigeration system. And also for this experiment, I will send the values by an email. And we turn off the generator 3. In this case, it is again in normal situation. All solenoid valve 4 and 6 are normally closed, but for the lack of refrigerant experiment, we turn on the generator 4. In this case, the liquid refrigerant is accumulated in the accumulator, and thus the refrigeration system will have a lack of refrigerant to perform a cooling process. So we can turn off this. I basically explained the system and the experiment. I will send all recorded values that you need by an email, and you can ask me your questions via email. In laboratory manual, you can find information for the report, and also you can find all the formulations in the laboratory manual. Thank you for watching.